As we talk about and study cosmology, cosmology is that evolution and birth and life of the cosmos, the universe. One of the cornerstones of the cosmologic principle is this. On a large scale, the universe is homogeneous and isotropic. Okay, what does that mean? Homogeneous means the same density of matter in all directions. If this is us, we are part of the Virgo supercluster. If you look at the universe in any direction, left, right, up, down, north, south, when we are at various points around the sun, it has the same density of matter in all directions. What does that mean? That means the universe does not look like this. It doesn't look like a lot of matter here and then less and less and less. It looks the same density in all directions. It's kind of like cutting through a well-made cake. The amount of bubbles and density of the cake is the same from the top to the bottom, to the left, to the right. It also means there is not a favored direction, and that can be confusing because we're not used to that in life. If there was an explosion, then we're used to things being very dense and then scattering outward. But that's not what we see. So the universe is homogeneous, same density of matter in every direction. It is also isotropic, meaning that it looks the same in all directions. It doesn't look differently if you look left, right, up, or down. Again, this is proof or evidence that there is not a favored direction to the universe. Again, that gives us a big clue about the fact that the universe is expanding all the time. It is not like it was, everything is moving from the left to the right. There's motion in all sorts of directions. Yes, we found Laniakea and some of these superclusters with some motions included, but there is not a preferred axis or orientation. So what's going to be the ultimate fate of our universe? It is a huge question. The big questions are, where did we come from and where are we going? Well, where we're going in the entire universe is going to depend totally upon gravity. How much gravity is there in the universe? And gravity is created by matter. Gravity is defined as matter being attracted to all other matter, causing a curvature of space and time. Well, as we try and determine what's going to happen in our future, we need to know how much matter there is in order to determine how much gravity to determine the fate of the universe. Scientists have come up with the three possibilities. There are three possible futures of the entire universe. Those three futures are referred to as open, closed, or flat. And you will see, and we'll talk a little bit about each of these, you will see each of these described by a kind of geometry. Flat is the geometry of a flat plane. If you took high school geometry, you did all of your geometry on a flat piece of paper. But there are other kinds of geometry. If you take more advanced math like I have, you will do the geometry of spheres. Well, the classic example or way to differentiate these is on a flat surface. If you have a triangle, the sum of all the angles is going to equal, the sum of the angles is going to equal 180 degrees. If you have a sphere and you're doing the geometry on a sphere, then the sum of the angles on that sphere are going to be more than 180 degrees, because each one of these angles is actually much bigger than 90 degrees. Third different kind of geometry is the geometry of what's referred to as a saddle. The geometry of saddles, so we're talking about curved surfaces. These saddles, because of the fact that they kind of dip inward, the sum of the angles in these saddles is actually less than 180 degrees. So very different, complicated forms of geometry. This all was proposed back in the 1920s by Russian astronomer Alexander Friedmann. And there is a constant, omega, that can be calculated for all three of these, a flat, open, or closed universe, based on the density of matter in the universe over the critical density. And the critical density is the density of matter allowed for the universe to expand forever. So determining how much matter there is in the universe will help determine this omega constant and then the possible futures. So let's talk about these possible futures. If the universe is closed, meaning that this omega constant is greater than 1, and meaning that the geometry is going to be the geometry of a sphere, what that would mean is that the universe has enough mass in it so that the rate of expansion is going to slow, stop, and reverse. Meaning there was a Big Bang. The Big Bang, and I'm going to draw it slightly differently, the Big Bang happened here. Matter was spewed out in all directions, and that because of the amount of mass, it will gravitationally tug everything back together, and there will be a big crunch where all the matter in the universe will slam back into each other. And many people think this is the ultimate recycling because this would then give birth to a new Big Bang. Now, I admit from a purely philosophical standpoint, I like this one because I kind of like the idea that the universe would have no beginning, no end, and it would keep just going on and on and on forever. But we are not certain that this is true. The other possibility is that we have a flat universe, an omega of 1, and that the geometry of the universe is closer to the geometry you learned in high school with the geometry of a flat plane. If that is true, the current rate of expansion that we see will eventually slow down. So we had the Big Bang, the universe is expanding outward, and this would mean that the rate of expansion would slow and slow and slow, and it eventually would just stop expanding and it would stop. There would be a finite size. There would be an end where the universe basically stopped expanding. And eventually, all the clocks would run down to 0. Everything would get very, very cold. And the universe would die in kind of a whimper. This is also called a critical universe. But that is another possibility. Third possibility is the hyperbolic or open universe. This would mean an omega factor of greater than 1. And what that means is that the universe would keep expanding forever. So there was the Big Bang, the expansion outward, and there is not enough matter to slow down the expansion, and it would keep getting bigger and bigger forever. Meaning that every galaxy would get further and further away from every other galaxy. Eventually things would get very, very cold, very far away, and again the universe would end in a cold, dark cinder. So what kind of universe do we have, since all three of these have been proposed? Well, prior to the 1920s and Hubble and all the things that were discovered at that point in time, it was believed the universe was flat and finite, meaning normal flat plane geometry worked. There were edges. They believed that you could get to the edge of the universe in the same way that when Columbus was sailing across the ocean, well, I guess it wasn't Columbus. Prior to Columbus, there were people who hypothesized that you could fall off the edge of the earth. I think that's just humans kind of run back to the same silly notions when we don't know stuff. And the fact that there was an edge to the universe, nobody said there had to be an edge to the earth, and nobody says there has to be an edge to the universe. But that was back in the 1920s. That was 100 years ago. So of the three kinds, open, closed, and flat, which one do we have? All three of them allow for expanding universes, and that's what Hubble showed. Hubble showed that our universe is expanding. So the expansion of the universe says we could have all three. Current data, what do we believe right now? The best answer at the moment is that we have a flat universe, that it will continue to expand and expand and expand, until it stops, the rate of expansion will slow and it eventually will stop expanding. Now, the reason I've got this lady sitting here going, huh, is because that's not the end of the story. Well, of course it's not, because science never really ends. But there is more data that we know of and have known of in the last 20 years to complicate this issue. And that is the concept of an accelerating universe. And we'll talk about that next.